To all of you, in previous session we have seen how to identify convolution by using graphical method, tabular method and matrix method. Today we will be looking at the mathematical method. So we are identifying convolution to identify the response of given discrete time, linear time invariant system. So to analyze the behavior of given detailed time system, we are using convolution. And out of the three methods we already seen, we will be looking at the fourth one. Okay. So again, we'll be solving this example where we have been provided with two sequences, that is impulse response and the input signal, right? So impulse response comprises four samples, while input signal comprises three samples, and you have to determine the response of the system. Okay, that means you will be identifying y of n, okay, by using convolution summation. So formula for convolution summation is k minus infinity to infinity x of k into h of n minus k. This can be also represented as x of n convolved with h of n, right? So here we will be considering this h of n as h of k and x of n as x of k. So as in previous example, we identified the total number of samples in y of n. So here also we will be identifying total number of samples in y of n. So we will be identifying, so it will be total number of samples in x of n plus total number of samples in h of n minus 1. Okay, so in x of n there are three samples, in h of n there are four samples minus 1, so there will be total six samples, okay, in the resulting sequence y of n. Okay, similarly you will be identifying the start time of y of n. Okay, so that will be the lower limit of x of n plus lower limit of h of n. So you can say that start time of x of n plus start time of h of n, right? So x of n is starting at 0, right? So it will be 0 plus, so in x of n, n is varying as 0, 1, 2, right? So it is starting at 0, ending at 2. The sequence x of n is starting at 0 and ending at 2, while in h of n sequence is starting at minus 1 and it is again ending at 2. Okay, so 0 plus minus 1. So the start time for y of n will be minus 1. So the values of n in the resulting sequence, that is in y of n, will vary as minus 1, 0, 1, 2, 3, 4. Okay, so likewise these six values will be there. Okay, minus 1, 0, 1, 2, 3 and 4. So these these six values of n we have to substitute in y of n, okay, and we have to compute y of minus 1, y of 0, y of 1, y of 2, y of 3, y of 4, right, mathematically. So again here, to compute it mathematically, you are using the formula k is equals to minus infinity to infinity x of k into h of n minus k. Okay, so initially we will substitute n is equals to minus 1 in this formula. So it will be y of minus 1 summation k is equals to minus infinity to infinity x of k into h of minus 1 minus k, right? Now in this formula you can substitute various values of k, right? So if you find here in x of k, k is varying from 0 to 2. Okay, so it will exist only for 0 to 2. Similarly here k exists for minus 1 to 2, right? So if I am substituting k is equals to 0, right? So it will be x of 0 multiplied by h of minus 1 minus 0. So it will be h of minus 1 plus, if I am substituting k is equals to 1, so it will be x of 1 into h of minus 1 minus 1. Okay, so it will be h of minus 2 plus, similarly if I am substituting x of 2 into, it will be h of minus 1 minus 2, so it will be h of minus 3. Okay. Similarly, if I am substituting k is equals to minus 1, so it will be x of minus 1 into h of minus 1 plus 1. It will be h of 0, right? So likewise again you can substitute on left hand side different values of k, but x of minus 2 is 0 as per the given sequence. There is no value present at k is equals to minus 2 or n is equals to minus 2, so that means it is 0. So we need to substitute it. Okay, so this x of minus 1 is 0, basically x of 0 into h of minus 1. So what is the value of x of 0? X of 0 is 1, right? And h of minus 1, h of minus 1 is 3. Okay, so it will be 1 multiplied by 3. Okay, then x of 1, what is the value of x of 1? X of 1 is 0, right? And h of minus 2, again h of minus 2, there is no value, so that means again it will be 0. So it will be simply 3, right? Similarly you can identify it for, so this is the value of y of minus 1. Y of minus 1 is 3. Similarly next value you can substitute n is equals to 0. So you will get formula y of 0 is equals to summation k is equals to minus infinity to infinity x of k into h of 0 minus k. That will be minus k. Again if I substitute various values of k, so I can substitute k is equals to 0, so it will be x of 0 into h of 0. Right, if I am substituting k is equals to 1, then it will be x of 1 into h of minus 1. If I am substituting k is equals to 2, so it will be x of 2 into h of minus 2, right? Plus again if I am substituting minus 1, x of minus 1, h of 1 will be there, x of minus 2 into h of 2 will be there, right? Okay, so again x of, as per the given sequence, x of minus 2, x of minus 1, these values are 0, right? So x of 0 and h of 0, x of 0 is 1, h of 0 is 1, right? So 1 multiplied by 1 will be there, plus x of 1 multiplied by h of minus 1, so x of 1 is 0 and h of minus 1 is 3, so it will be 3 multiplied by 0, right? 0 multiplied by 3. X of 2 is 1 and h of minus 2 is again 0, right? So again it will be 0, so it will be simply the value which will come here, it will be simply 1. Okay, so y of 0 will be 1. So likewise again you can identify it for n is equals to 1. Okay, so when you are identifying it for n is equals to 1, it will be y of 1 is equals to summation k is equals to minus infinity to infinity x of k into h of 1 minus k, right? Again you are substituting values of k here, so it will be x of 0 into h of 1, right? Plus x of 1 multiplied by h of 0 plus x of 2 multiplied by h of minus 1. Okay, so 1 minus 2 will be there, right? So it will be h of minus 1. X of 3 is not there, so it is 0 basically. Similarly this x of minus 1 is 0 as per the given sequence. So if I am substituting minus 1, so it will be h of 2. 1 minus minus 1 will be h of 2. So similarly this x of minus 2 is 0, so no need to compute it. Again in given sequence x of 0 is 1 multiplied by h of 1 is there. Okay, so 1 multiplied by 2 will be there, right? H of 1 is 2, x of 0 is 1. So 1 multiplied by 2 will be there, x of 0 is 1. I will write these sequences here, okay, for your understanding. So x of n is, I think that sequence 1 0 1. So it is 1 0 1. 1 is at origin, and here h of n, h of n is 3 1 2 minus 2. 3 1 2 minus 2. Okay, 3 1 2 minus 2. Okay, so origin at 1. Okay, so x of 0 is 1 here, right? H of 1 is 1. So sorry, h of 1 is, x of 0 is 1 and h of 1 is 2, right? Plus x of 1 is 0. Okay, multiplied by h of 0. H of 0 is 1 plus then x of 2. X of 2 is 1 multiplied by h of minus 1. H of minus 1 is 3, right? X of 3 is not there in the sequence, so it will be 0 simply. Okay, so again this addition will be 2 plus 3, that will be 5. So this is the value of 1. Similarly, you can identify it for n is equals to 2. So again formula will be y of 2 is equals to summation k is equals to minus infinity into infinity x of k into h of 2 minus k, right? So again here I can substitute values of k, so it will be x of 0 into h of 2, okay, plus x of 1 into h of 1, okay, 2 minus 1 will be there, so it will be h of 1 plus x of 2 into h of 2 minus 2 will be 0, right? X of 3 is not there, okay, in the given sequence, so I'm not substituting it. Similarly on negative side, plus here x of minus 1 is not there, okay, so again it will be 0, it will be coming 0, right? So h of is 2 minus minus 1 will be h of 3 basically, okay. So here again x of 0 you can identify it as 1, sorry, x of 0 is 1, right? Then h of 2 is minus 2, right? So h of 2 is minus 2 plus x of 1 is 0, right, multiplied by h of 1 is 2, right, plus x of 2 is 1, right, multiplied by h of 0 is 1, okay. So again the addition will be, this is minus 2 plus 1, okay, so it will be minus 1, that will be pi of 2. So you will be identifying total 6 samples as n is varying from minus 1 0 1 2 3 4, okay. So till now we identified 4 samples, so next we will be identifying it for n is equals to 3. Again I will rewrite the sequences here, okay. So here x of n is 1 0 1, okay, 1 comma 0 comma 1 originate first one, right? H of n is 3 1 2 minus 1, okay, 3 1 2 minus 2 originated this one, okay. So for n is equals to 3, again I will write y of 3 is equals to summation k minus infinity to infinity x of k into h of n minus k, that is 3 minus k. So again if I am substituting values of k here, so it will be x of 0 into h of 3 minus 0 will be 3 plus x of 1 into h of 3 minus 1 will be 2 plus x of 2 into h of 3 minus 2 will be 1, okay. And then again x of 3 is not present in the given sequence, okay, so this will be 0. Similarly x of minus 1 is not present, so again it will be 0. So x of 0 is 1 multiply h of 3 is not there, so it will be 0. So plus x of 1 is 0, right, multiplied by h of 2 is minus 2 plus x of 2 is 1, right, multiplied by h of 1. H of 1 is 2, so it will be 2, right? Simply, so this is what, y of 3. Similarly, for n is equals to 4, formula will be y of 4 is equals to summation k minus infinity to infinity x of k into h of 4 minus k. Okay. So again, it will be, I'll substitute k is equals to 0, so x of 0 multiplied by h of 4 will be there, plus x of 1 multiplied by h of 3 will be there, plus x of 2 minus h of 4 minus 2, that means h of 2. Again, x of 3 is not there, x of minus 1 is not there, x of 0 is 1, right? H of 4 is 0, x of 1 is 0, h of 3 is 0, right? Plus x of 2 is 1, okay, h of 2 is minus 2, so it will be simply minus 2, so that is y of 4. Okay, so that those will be the required samples, okay, because n is varying from minus 1 to 4, okay, that we identified here. N is varying from minus 1 to 4. So finally you can write down the response of given LTI system. LTI system is, you will simply list out those sample starting from minus 1, okay. So at minus 1 value is 3, then 1, so y of minus 1 is 3, y of 0 is 1, so it is 3, 1, originator 1, okay. Then for n is equals to 1, it is 5 minus 1, okay, y of 2 is 1 minus 1, then it is 5 and minus 1. Similarly, y of 3, okay, y of 3 is 2 and y of 4 is minus 2, so 2 and minus 2. So this is the required sequence, okay, that is the required response of the given LTI system, okay. So here we have discussed how this convolution can be computed mathematically simply by substituting the values of sample values of the given sequences in the convolution formula. Before this, we have already discussed graphical method, tabular method, and matrix method. So if you have given with any example to identify the response of the given system, so if it has been asked for 7 marks, 6 or 7 marks, they can use, then you can use any one of these three methods, that is graphical method, tabular method, or mathematical method, okay. Matrix method you will be using only for verification of your answer, right? And or if the problem is asked for the 2 marks, then you can use the matrix method. Otherwise you can use any one of these three methods, that is graphical, tabular, or mathematical, right? Again, in problem, if it is explicitly mentioned that use graphical method for the identification of convolution, or use tabular method, or use mathematical method, then you have to use that method only, okay, which has been specified in the, which will be specified in the example itself, right? So in next session we'll be discussing the properties of convolution, okay. So we'll be discussing that topic in the next session, that is nothing but properties of convolution, okay. Thank you for joining today's session.